ikfk blending. So now that we have set up our FK and IK control rigs, let's have a look at how we can set up a FK-IK blender so we can switch between the two control modes. But before we look into that, I noticed that our FK control rig is not quite set up correctly, because if you look at the y-axis, it's pointing in the upwards direction, and for the IK it's pointing in the backwards direction, and we wanted it to point in the backwards direction, and that's because the arm is straight now and we have not set up the orientation of the FK controls correctly to handle a straight arm correctly. So if we take the lower guide for example and introduce a small bend into the arm, you will see that the y-axis is correctly pointing in the backwards direction. So it's working correctly when the arm is not straight, but as soon as if we make the arm straight, then the controls point in the upwards direction. So if we look at the setup, here we have the upper control for example, and we create the oriented guide matrix. We are using the aim mode still for the secondary setup, and we are pointing from this matrix to the lower matrix and using the hand matrix as an up matrix. But as they are in a straight line, there is no logical way to determine what is up. So Maya just points in the scene up direction. So we have to correct that and make it work the same way as we have set up the IK orientation plane for the arm, by using the alignment, where we align the plane to the guide z-axis. So if we go to the aim matrix of the upper arm, we can change the secondary target matrix to be the upper guide, because we're going to use its z-axis. So let's take the world matrix of the upper guide and plug it into the secondary target matrix of the upper guide aim matrix. And then we want to align the y-axis into the we align it with the negative z-axis of the guide, because the upper guide z-axis is pointing forward. So if we take the negative z-axis, then we are pointing backwards. So if we now look at the control, we see that the y-axis is nicely pointing in the backwards direction if the arm is straight, and still if the arm is bent as well. So let's do that for the lower arm as well. So the lower arm already has the secondary target matrix connected to the upper guide, because we use that as an up object. But now we're not going to use it again as an aim, but as an alignment, and we are aligning the y-axis of the matrix with the negative z-axis of the upper guide. And now the lower control is also nicely pointing backwards, and the hand control is using the same orientation as the lower, just with an offset, so that's correct now as well. So having fixed that, we can continue to setting up the actual blending of the IK and FK. So first let's create a control to dock the IK-FK switch attribute on. So I already prepared a control curve, and let's add that to the rig as well with a guide. So let's create a locator, and let's call this the arm left settings guide, and position it somewhere here for now. And then using the same method as before, we're going to use the parent and the parent guide to calculate the relative offset matrix and move it along with the rig. So let's make a node matrix node and take the guide world matrix and plug it into the first slot, and then take the world inversion matrix of the parent guide and multiply it, and then we have the relative offset from the guide of, in this case, the root control to the guide of the settings control. Let's fix the color real quickly, like so. So let's call this the guide print offset matrix. And then let's get the control, add it in here, and then we have to use another build matrix node where we plug in the offset matrix or buffer matrix and then multiply it with the world matrix of the parent control, which in this case is the parent input because it's relinked to the output of the root module, which connects to the world matrix of the root control. So we take the offset parent matrix of the input, parent input, and then we have created the settings control world matrix. And then we can plug the matrix sum into the offset parent matrix of the settings control. So now when we move the main control, the settings control moves along, and as well if we move the guide, the control moves along to the orientation of the guide. So that's set up correctly. And now let's add a control for switching. So let's add an attribute. I already hid all the transform, rotate, scale and visibility attributes on this control. So let's call this use fk, use ik, and then let it go from 0 to 1 with a default of 1 because I want ik to be on by default. Okay, so you could also call this fk ik switch, but in this case it says if use ik is 1, it's clear that 1 equals true, so if it's 1 then ik is active. If you have an attribute that's called ik switch, then you're not really sure looking at the value which mode it is in, so I like this better. So let's go to my ikfk switch tab and add the settings control here. And then we need to switch between the IK and FK outputs of the control rigs. So for the IK, it's quite simple. We have constructed these temporary locators. So let's add these in here for now. The upper, lower, and hand. And for the FK, we are going to use the actual control world matrices for now. So let's look these up in our graph. So we have the upper FK control, lower FK control, and the hand FK control. And let's add these two. So we have the upper FKIK, lower FKIK, and hand FKIK. So what we can now do is create a blend matrix to blend these two matrices into one another. So let's create a blend matrix. And if we then take the world matrix of the FK control and plug it into the input matrix, and take the world matrix of the temporary IK locator, we're going to swap that in the near future for the actual input, but for now we're going to use the locators because it's selection is clear in the viewport what it is, and plug it into the target matrix. And then if we look at the attribute editor with the target, you can see that it blends the first input, so the IK, blends it into the input matrix. And if the weight is 0 or the weight is 1 and use matrix is on, then the input matrix is completely overridden with the secondary input, so with the first target input. If you set the weight to 1/2, it will blend a half between this matrix and that matrix, but this way it will override. So if we now connect the settings attribute, the use IK, to the weight in the blend matrix, we now have a way to blend these two matrices from the FK matrix to the IK matrix, and then we can output this onto our I prepared some temporary geometry pieces. So let's take the upper geometry piece so we can easily see what's going on. and take the output matrix and plug it into the offset parent matrix. So now we have our upper arm at the correct position. And if we have use IK on, so the IK is enabled, we can see that if we now move our IK control, that our arm moves along with it, and if we rotate our IK elbow control, that our arm correctly points in the same direction. Okay, so let's call this the arm left upper to be correct. So let's rename this quickly. Okay, so let's call this arm left upper world matrix. You could also call it ikfk blend, but I like to call it what it is, and it is the world matrix for the upper arm segment in this case. So let's do it again for the lower arm. So let's make a blend matrix. And we take the world matrix of the FK control, plug it into the input matrix, and we take the world matrix of the IK locator and plug it into the target matrix, and then we take the use IK attribute and plug it into the weight, and then we take the lower mesh, and then we plug the output matrix into the offset parent matrix so that it's at the correct position and orientation, and then we call this lower world matrix. And then for the hand we can do the same, so let's make another blend matrix. We take the hand world matrix, plug it into the input matrix, and we take the world matrix of the hand IK temp locator and plug it into the target matrix. And then we take the use IK attribute, plug it into the weight, and then we take our lovely hand geometry stand-in and connect it to the offset parent matrix, like so. And then we can rename this to blend world matrix. So now we have an option to use it in IK modus, and we have, if we switch this off, we can use it in FK modus. So we can switch between them. But now, if I were to set the, let's say we set him to IK, we move our hand up here, we rotate some, and then we take our FK and we move it down here and give it some random rotation. If we now switch the IK to FK in a gradual motion, you will see that as soon as I start blending, if my lets me, that the lower arm disconnects from the upper arm. And this is because we're using the worldSpace matrices to blend between for the lower arm. So the lower arm IK world matrix is positioned right here, and the FK world matrix is here. So the linear motion, the linearly blending these two matrices will result in a position that's on a line that goes linearly through these two matrices. So of course it will not be at the end of the upper arm. So we cannot use the world matrices to blend these for IKFK blending. We have to use the local matrices because we want to have the local rotation matrix relative to the upper arm to blend between the IK and FK, so we can have it relative to the upper arm motion. So to do this, we can simply replace the FK and IK world matrices with the local matrices. So if we want to take the lower matrix for the IK, we can just go into the IK solver tab I have saved, and then we can see that we originally calculated the local matrix and then we multiplied it with the world matrix of the parent. So the lower local matrix was multiplied with the upper world matrix to get the lower world matrix transformation. So we can just simply take this output from this node, which is already the local matrix relative to its parent. So if we now go to the ikfk switch tab and we add the node here, we can swap this locator for this. So we can take the output and reconnect the matrix. Of course, now it breaks, but we'll fix that in a minute. And for the lower fk, if we go to the control setup page that we that I stored, you can see that the fk control world matrix is composed of the local parent offset matrix, or the buffer matrix, multiplied with the world matrix of its parent control. But this is just the buffer matrix. It does not have the rotation of the control baked into it. So we have to create a new matrix that has the buffer matrix multiplied with the lower matrix, the local matrix of the lower fk control. So let's make a multi-matrix node. And because if you think in hierarchy, then the lower fk control would be a child of the buffer group. So this is the child, so it should be the first input into the multi-matrix node. And if we then refresh the inputs and take the buffer matrix output, we now have a new matrix, which is the matrix that gets us from in this case the fk, so the fk parent control, to the rotated child control, the fk lower control. So it is the matrix that gets us from this to this. And that's the local. So let's call this the fk and then local matrix. And let's add this to the ikfk switching tab. So here. So if we now plug this matrix to here, and then we can remove these from the display. So not delete them, just remove them visually. And now we have a lower IK switch, which is happening in localSpace. So if we now take the control and use the ikfk switch, you can see the switching happening in localSpace with the offsets multiplied, or the buffers applied as well. But now we need to have this transformation local to its parent. So we need to use another multi-matrix node, because the matrix that we now have blended is relative to its parent. So we actually have to multiply it with its parent to get the world matrix. So we take the output matrix of the blend matrix node, and then we multiply it with the world matrix of its parent control, which is the upper control. And if we then plug that in, we can take the output and plug it into the offset parent matrix, and now we have a correctly blending lower arm. If we now blend, we see it breaks because I obviously made an error. So let's have a look. It goes wrong in the FK. So let's have a look here and see. Yeah, so I was talking about the local matrix multiplied with the buffer, and I connected the world matrix. So I wanted to use the local transforms, which are all composed into the matrix called matrix and not the world matrix. So we have to use the matrix plug, of course. And now we will see that it does work. If we switch back to the ikfk switching pane and then toggle the ikfk switch, we see that it does switch correctly. Well, the hand does not, but the lower arm does. We'll fix the hand just in a minute. And for the upper, by the way, we can leave it to switch between the world matrices, because the position will always be at the same position in worldSpace. So it's only blending the rotation and scale and the translation is not dependent on a parent node within this module. So we can safely switch between them without needing to worry about local matrix switching. So this can stay the same, and now we're blending the lower matrix in localSpace. So let's rename this correctly. So this is the local matrix, and this is now then the world matrix for the lower. So let's do the same thing for the hand. So for the hand IK, we can again just take the local matrix that we already created, because we created the world matrix by multiplying this local matrix with its parent world matrix, which was the lower IK world matrix. So we can directly take the hand IK local matrix for this and add it to the panel, and then swap the connection. And then for the hand FK, we can do the same thing as we did for the lower. We have the world matrix here, which is the input for the control, and we want to have the matrix that is a result of the local matrix of this control multiplied by the buffer matrix or parent offset matrix that we have here. So we create another world matrix node, and the local matrix, or not the world matrix, like the same mistake, let's not make the same mistakes as just now. So take the matrix plug it into the first, because this is the child and this is the parent in the hierarchy synonym. So take the parent offset matrix output plug and plug it in, and now we have the hand FK control local matrix. Let's call this out local matrix, because it's not the input, it's the output local matrix. So let's rename this as well, just for completeness. Out local matrix. So let's take this and add it to the panel here, and then we can reconnect the plug from the world matrix to the output of the local matrix, and then we can remove this from the display, and now we have a local switch happening for the hand. And now we need to do the same thing, because the hand is now switching in localSpace. So again, if we now switch, we can see the blending happening in localSpace for the hand. So we need to make sure that it is now in worldSpace. So we do another not matrix node, and we multiply the local matrix with the parent matrix where it is relative to. So we take the lower arm world matrix that we just created, plug it in the second input, and then we replug the connection to the hand. So now we have the world matrix position. Now let's rename this to the local matrix, and this one should be the hand world matrix. So now we can switch correctly between local spaces from IK to FK, and everything works correctly, even in between. Okay, so let's clean this up a little bit. We have the guide for the settings. We can parent it under the guides, and we have the well, we can lock everything except for translation, because we don't need anything else, I think. And then we have the control, which can be parented under the controls, and then these we can leave outside, and these we're going to remove, but first we're still using it here, so we need to take the input of this. So if we go to the IK solver pane, we can see that it's taking its input from the lower upper IK world matrix node. So we're going to add that to this panel, and then instead of taking the output of the temporary locator, we're going to take the output of the world matrix node. So this way we can delete the locator without destroying the rig. So this one can now be, they can all be deleted. If we look in the IK panel, this one has no, if we check the outputs, by the way, I always set this to 1, Maya sometimes resets this, and then you can safely check the inputs, and I always make sure that regraph connected nodes is off and additive graphing mode is on. So when you graph the outputs of a node, it is added to the graph and only one step at a time. So there's no output connection anymore. We can safely delete this one. Same goes for the lower IK. It has no output. Maya sometimes frames the whole graph if you do that. So you can safely delete this one. And the hand IK temp locator also has no output connections. I'm not sure why. If you press the graph output connections, Maya sometimes shows the whole graph, zooms out. It's just Maya being Maya. And we can delete this one, and this node has no output connections as well anymore because it was just used for the IK locator, the temporary IK locator. So we can delete that as well. So we're left with the local matrix only. Okay, so then let's reset our controls to their default values. So 0, and let's do that for the IK as well. So now we're back to normal, and we only have our temporary head geometry of arm geometry. Now let's say we wanted to introduce some joints into this. So let's create 3 joints like this, and then we leave the names like this for now. Place them in the right order. So what we can do for the first joint, the upper joint, so to speak, we can directly plug the world matrix that is coming out of the blend matrix node. You can plug it directly into the joint, like this. So plug it into the offset parent matrix, and now if we set, let's say, transparent joints or X-ray joints, we can see them. And for now, we want the child joints to have the local matrix as offset parent matrix. And you can compare what we did here. We have created the local matrix with the blend matrix between the IK and FK, and we multiply it with the parent world matrix, which is basically the same as saying, okay, if this was a child of this, then it would produce the world matrix for the lower mesh in this instance. So if the joint is already a child of the parent, then its matrix that we want to set is the local matrix. So we can take directly the local matrix out of the blend matrix and plug it into the offset parent matrix. And now, of course, the joint is at the wrong position because we gave it a translation of x1. So if we set that to 0, then the position and rotation will be correct. So in the same way, you have to check if you create your joints in the viewport and you do not do it in a straight line in the x-axis direction, then Maya will add some joint orients to the joint to get the rotation correct. But we don't want the joint orientation, so we want them to always be 0. So let's check for all these joints to see if they're 0, and that's the case. So that way we know that the local matrix that we generated is exactly what we will see for this joint. And that is what we want. So for the hand joint, the same thing. We want to remove the translation because we don't want to have any local transforms on this joint, because we're going to plug the local matrix that we generated into the offset parent matrix. So for this, the same. This is basically saying if this were a child of this, but we already have a joint that is a child of its parent. So, and now we are going to take the local matrix directly and plug it into the offset parent matrix. And now the hand joint is there as well. So this would be the way to go if you would want a joint chain that is in a hierarchy. I myself like my joints to be in a flat hierarchy as well, just like the controls, just like the guides, because let's say this is an arm, and then you would have some twist joints in between as well. And if they were all in a parent-child relationship, besides the point that you would have to calculate local matrices, if you have not already, that at itself is not such a big problem. But if you have this joint, for example, which can be directly calculated from the IK elbow and the FK elbow position. But if it were a child of all the twist joints in between, then the evaluation of this joint have to wait before all the joints of the twist joints matrices have been calculated. So the upper joint is calculated based on the IK upper and the FK upper, or depending if the switch is halfway, or if it's one way then it's the IK, if it's the other way it's the FK. But as soon as this joint or these controls are evaluated, and this joint was not a child of that joint, the FK control, as soon as the FK control was evaluated, this joint could be evaluated. So if there were a lot of twist joints in the scenario that this joint was a child, so it had to wait on every single joint. And if it was not a joint that was a child of this joint, then as soon as these controls were evaluated, then this control can be evaluated and this joint can start its evaluation, even though the twist joints are still being evaluated in the same time. So that you're utilizing the parallel evaluation in a better way if you have your joints live in, or if you calculate the joint matrices in worldSpace instead of in localSpace. Of course, this depends on the setup. If you don't have any twist joints, then in practice it will not change very much. But if you have other joints or other things going on in your rig, you want the evaluation of your object that you're looking at to be as quick as possible. So it should have the shortest route to the control matrix without any delays for waiting on other objects to be evaluated. So that's the reason why I like my joint hierarchies flat. So I would unparent these as well, and then Maya will, if you unparent, set the values of the translate and rotate to keep them at the same position. But if I now just set them to 0, you see that the joints are in their local matrix position, and I would then take the world matrix that I calculated and plug it into the joint, and then take this world matrix and plug it also directly into the joint. So now I have a flat joint hierarchy with no parent-child relationship, and the world matrix are plugged in directly into the joints. As well, there is another advantage to keeping your joints not in a hierarchy, and that is, we'll see this in a later video in this series, that if you have a world matrix generated for every joint and you do not use your local channels for your joints, then after skinning is done, you can take the world matrix for the joint and plug it directly into the skin cluster and then delete the joint altogether. So that saves a lot of nodes in the end. So you can do that in a post-publish script. When you publish your rig into the animation pipeline, then you can remove all joints, saving some computations when animation starts with the rig. So that's another benefit of keeping your joint hierarchy flat and creating absolute world matrices for every joint you're using in your rig. So let's rename these joints very quickly. And now that's out of the way, we can move forward. So I'll leave the meshes in for now for visual cues, and the joints are there for eventual skinning purposes of the rig. So there's one small thing we have to fix before we proceed. As I just unparented these joints because they were not oriented in the same way as the world orientation. And then when you unparent a joint, Maya bakes the current rotation in worldSpace onto the joint orient. So without wanting it, Maya set the joint orientation to a specific value for the joints, and we have to remove that. It will not have mattered a lot because we're going to use these joints as world matrices in the skin cluster, and then the joint orient doesn't really wreak havoc or something, but it's nice to keep it clean. So removing the joint orients from the joints after unparenting it. So when unparenting joints, unparenting them and changing hierarchies, always be aware that Maya sets these values on the joint orient and the translation of the joints.